Two examples on solving systems by addition. We have still linear systems, so two linear equations, and we could solve this by substitution, but it can tend to get a little bit messy. And so another technique that can make things easier sometimes is getting one of the variables to cancel out in another way. So how is that? I'm going to focus first here on the y variable. So I have 3y and 2y. I want those to match. That's the main point. How can I get them to match? I can do that by multiplying each equation. I can multiply an equation by any non-zero number and I still preserve the same solutions. So I'm going to say the common denominator of 3 and 2 is 6, or the common multiple. So I'm going to multiply the top by 2, so I'll get 6y, and the lower equation by 3, so I will also get 6y. So I'm trying to get them to match. That's how I chose the 2 and 3. But I actually want them to cancel, so I'm going to make one of them negative. All right, now let's see, how does that work out? Why does that make our life easier? So if we multiply, then on top, I'm going to have 12x plus 6y equals negative 24. And for the second equation, I have negative 48x minus 6y equals positive 96. Now, this is what I wanted. You can see here that the y's, when I add them, they cancel. I have 6y minus 6y will give me 0y, and it's gone. That's the whole goal of the addition method. So let's add them. 12 minus 48, that gives me negative 36x. 96 minus 24, that gives me 72, positive. And then I'll divide both sides by negative 36. And we get x equal to negative 2. That's half of our solution. We take that, take that, negative 2, and plug it in for x into one of our equations. I'll choose the top one. So that's where that's going. So that will give me 6 times negative 2 plus 3y equals negative 12. There is my substitution right there. So now we have a little bit more work to solve for y. These questions are multi-step. Don't rush. Watch for the negative signs. That's where a lot of people make a mistake. So 6 times negative 2 is black. Negative 12 plus 3y equals negative 12. Let's add 12 to both sides. And we get 3y equals 0. Divide both sides by 3. And we get y equals 0. Now we have our two coordinates. So our solution is negative 2, 0. That is the point. Those are the coordinates of the point that satisfy both of those equations, which you could check. You could plug them into each equation and you should get equality, that it would satisfy. Let's look at another example. See if it's making sense. So I am going to focus on the x this time. They're parallel. You could do y just as well, but I want to show you something about these. So I want these to match. Common multiple of 3 and 4 is 12. So I'm going to multiply the top times 4, so I get 12x, the bottom by 3, so I get 12x. And then I'm checking, will they cancel? The top equation, the first equation will give me positive 12x. Second equation will give me negative 12x. That's good. Those will cancel. So this time I multiplied by both positive 4 and positive 3. Where the last one, it was a positive 2 and negative 3. You make those whatever you need to so they'll cancel, whether you need to make one negative or not. You look at that. So what do I get multiplying? I get 12x plus 12y equals 4 times 27. So we get 108. Then I get negative 12x plus 12y equals negative 60. And we accomplished our goal, of the x's canceling out when I add them. So I now have 24y equals 108 minus 60, which is 48, divide by 24. Now these came out whole numbers, but they don't have to. You could have fractions. That's legal. It could be all kinds of fraction answers. 48 divided by 24 gives us 2. So y equals 2. That's halfway. We're not done yet. We now need the other coordinate. So I'm going to choose the top equation. I'm going to plug this 2 in for y. So I get 3x plus 3 times 2 is 27. So 3x plus 6 is 27. Subtract 6 from both sides. 3x equals 21. Divide both sides by 3. X equals 7. Now we have our solution, 7, 2. These are the coordinates of the point that lies on both of these lines.